Good morning. This video is going to be a little bit different. It is done specifically to answer a question by Miss Kelly Ross, whose mom was my elementary school PE coach. And so just bear along with us. This is going to be a lot more stats and less kind of updating. The 1 day update from yesterday was this 500 to 800, almost 900 count jump. And so that is not great. It is probably a little bigger than we expected. And it shifts in the total number of deaths, is what we're, the daily number of deaths. And it shifts our peak number from the 2,200 we had predicted at the peak nationwide to 2,600. And so again, these things, they shift. There is no one number. And that's what Kelly's question was. Kelly's question was, if you're predicting 82,000, 84,000, why is the White House predicting 100 to 200,000? And that's a fair question. I will have you notice, first of all, that while the peak number is higher at 2,600, the overall prediction of total deaths, however, still remains about the same. We're still at about the 94,000. And I think that's due to the actual curvature. The fact that this looks more like a slide than it does a traditional normal curve is probably why the total death number actually went down from yesterday, if I remember correctly. But we have this peak. And so everybody's worried about the peak. That 2,600 is the problem there. And so that 2,600 went from 2,200 to 2,600 because yesterday to today we had a big jump. But we're still expecting this normal curvature to jump out here. And I want to answer some of her questions there in terms of our normal deaths. So first and foremost, this is going to be more into the weeds on the stats side. And so if you're just jumping in for the update, well, there's the update. But if you're interested in the math, this is the math. And I talked a little bit about this on my very first video. This is basically a varied approximation of the normal curve. And so we developed a curve fitting tool for nonlinear mixed of blah, 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 blah. The cumulative death rate for each location is assumed to follow a parametrized Gaussian error function. That means that we expect the total death count, the cumulative death count, to approximate a normal distribution. That's our assumption here. Why did we make that assumption? We made that assumption because that's kind of what we saw with the first distributions. Again, the actual event is not a normal distribution, but the normal distribution is the closest parametric model that we have to approximate it. So we basically, again, looked at the China data, saw that it looked like a normal distribution, and said, this is the best, most common model that we have that is still sophisticated and looks like it's a good fit. And so we use that curve to pick this model, and then we use this model to draw our curve. But Kelly's question is, Kelly's question is very well taken. And so why is our number why is this number predicting a total eventual deaths of now 93,000 as opposed to, oh wait, I was wrong, it's 93,000. We had predicted 84,000, so this is higher. My apologies. Why are we predicting 94,000 as opposed to the White House's 100 to 200,000? And so this model takes a couple of different approaches in the modeling, and this is where, knowing the math makes a little bit of a difference. Where to go? And so this one has a modification for social distancing. If I'm on the wrong one here. If the area has included one social distancing measure, then we modify from 100% of estimated hospitalization growth or estimated cases down to 67%. That's what that one means. With 2 measures, we bump that down to 0.33%, and with 3 or 4 measures, that gets down to 0%. Now, that doesn't mean that there are 0% in cases that are contracted. It means that the additional exponential growth of those cases get knocked down. And what are those? Those are school closures, non-essential business closures, including bars and restaurants, gathering place, right? Stay-at-home recommendations, and travel restrictions. So those are the 4 big deals. If we are doing those 4, if you're doing one of those, then you get 0.67. If you're doing 2 of those, then you get 0.33. And note that that's just a third, right? That's 2/3, that's 1/3. Again, this thing is fairly new, and we don't know what the actual effects are. And so these are simple approximations that get plugged into this model that says there has to be some effect. We know that there is some effect. We may not know what the actual number of that effect is, but it's something, and we just plug it and play it, and we know that there's going to be an error rate. Which brings us to Kelly's point. Why are we approximating 100 to 200,000 if you're estimating now, different from yesterday, if you're estimating 94,000? Well, we're estimating 40,000 down here at the bottom. You know what? Let me do this. This was working real well the other day. This worked really nicely the other day. Where's my pen? We are approximating 40,000 up to 170,000. And I think yesterday we were approximating up to, I think our line was like over here somewhere. And so clearly yesterday to today's bump has bumped our forecast even more. And again, all of these forecasts are going to change on a day-by-day basis because the numbers are going to be high on one day, low on the next, high on 2 days, low on 2 days. And so we're just going to keep doing this until we get to an actual number and everybody backs off. But at least there's enough here to make some decisions. And so what I want to do with you is look at, I want you to pretend that we're going to take a sliver of this information here. Pretend we're going to cut out, oh, that is a terrible, terrible sketch. Pretend we're that is really bad. Pretend, I don't know how to draw a straight line on here. Oh, yes, I do. I have a ruler. How does this work? Oh, look at us. We're learning stuff all the time. Oh, I'm rotating it. I'm rotating it. This is working. It was working. I'll have to learn how to do this. Sorry. I'm going to have to learn how to do that and play with it later. Let me get rid of the ruler. The point is, I want you to take this sliver of data, okay, where the bottom of the data is 40K and the top of the data is basically 180K, and our estimation here is 94,000. So this is 94, 40, and 80. Think of that for a second as if it were a normal distribution, and we're going to draw a normal distribution or a version of the normal distribution this way, okay? 40, 94, and 180. So let me go to my whiteboard. Oh, this is from my actual stats class. Look at that. All right, so let me get some whiteboard. And here's what that normal distribution looks like. 40, and here in the middle, we're expecting the 94, and then over here is 180. And now we have this normal distribution that looks something like this. And it doesn't really. The actual 40 is actually closer to here, given the spacing, right? So that is actually, that's a terrible curve. Let me see if I can do a better one. Something like that. But yeah, 40 is actually over here somewhere, más o menos. Now, if this is a normal curve, and these are total deaths, then we are turning around and saying, hey, the expected value, the expected average, you'll see that, like we don't know what the actual number is going to be, and nobody does either. And so the expected number is kind of predicted at 94. And you saw that yesterday we were predicting 84. We had a change in the data. Now they're predicting 94 and so on. Why don't we just say 100 to 200 like the White House? Well, we don't, because the White House is saying that their numbers are 100 from here to 200 from here. Now, the probability that that is correct, assuming that they're doing this at 3 standard deviations, 1, 2, 3, 1, 2, 3. Let's call this one 80 because it'll make more sense. Assuming that this is going to happen, there is a percentage chance of what that's actually going to occur. So there's a 50% chance, if I shade in this area, there is a 50 from here this way, there's a 50% chance that one of these numbers is going to be correct. And there's a 50% chance that one of these numbers on the right-hand side is going to be correct. So what do? We can draw a number. If you're a pessimist and you go to the 180 number, you say, hey, what are the opportunities that the probability that the total number of deaths is going to be, you can't really say equals to because it's a single number, is going to be less than 180,000? Well, that is all of this all the way out to the left-hand side. And so there's a 99% chance that it's going to be less than 180,000, right? Let me do another one real quick. What is the probability now that the total number of deaths are going to be greater than 180,000? Well, that is, let me change colors. This is one of my little favorite little rainbow colors here. That is this area over here, right? Or if this is 99% on the left, then I'm looking at this one, 0.01, or there's a 1% chance that it's going to be greater than 180. And so what should you be asking is does this model's $94,000 correct? Well, there's a 50% chance that the number's actually going to be smaller, and there's a 50% probability that the number's actually going to be bigger. And so why are they predicting 40, or why are they predicting 100 to 200? Because this is what the extremities look like. Now let's be very, very certain, not certain, but let me be very, very clear that the probabilities of going from 100 to 200 are different from the probabilities of knowing this other number. So what's the reality? The reality is that we're going to be in here somewhere. At 1 standard deviation, from here to here, we have about 67% probability, right? There's a 2/3 chance that we're going to be somewhere between, say, 70 and 120. I don't know what the actual numbers are. We could calculate them, but there's a 67% chance that that's the case. And now to answer the other question, why is, if this 40 is our number, if we're predicting 40 to 180, and the White House is predicting 100 to 200, what's the difference between the two models? This model mathematically takes into account social distancing measures. My assumption, and I don't know this to be true, right? I don't know that this is the case or not the case because I don't know what the White House model looks like. My assumption is I know that this model takes social distancing into account. I don't know that the White House modeling takes social distancing into account, and that would be my guess because everybody's working off of the same numbers. The models are just going to be a little different. I would also expect that their numbers they're going to hedge conservatively in terms of total deaths because they don't want to come out of this thing after the fact and say you predicted 50 and we ended up with 150. And so that's why this curve looks the way it looks like. That's why our numbers are, that's probably why our numbers are smaller than their numbers. And hopefully that was helpful in explaining that bottom range and top range. But let me say it again because it is, where did I put it? It is really important to note that when we talk about range numbers, it's not like there's a unilateral distribution that it could be this or 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 this, right? The greatest probability is that we're going to have a number that's in the middle here somewhere. It's more likely that we're going to be between 70 and 120, it's unlikely that we're going to be at 40,000. It's unlikely that we're going to be at 180. So when the White House says their 100 to 200 number, you should be thinking they're probably expecting something in the 150 range, and that is different from Serge's prediction because, and it's not mine. Again, it's IMHE's. But this is exactly what I would be doing if I was modeling this from scratch. Why is Serge's smaller than that one? That's probably why. Because this particular model that we're working with takes into account social measurements. And the White House's may or may not, I don't know. That's my guess. Hope that answers your question. It was kind of bothering me all night. There you go. Good luck. See you guys in a couple days.